Hello, my name is Ted, and this is another digital signal processing and radio astronomy, or DSPIRA video. This is a companion video to go along with one of the astronomy lessons, How Fast Are We Moving? I teach astronomy at my school. I teach this lesson, and very often I have a wide variety of math abilities in my class. I might have honors physics students that have moved on and are curious about astronomy, and an assignment like this is very easy for them. They are very familiar with the nature of the circle and the circumference, so they can come up with that equation very quickly. Other students that have kind of bounced around finding their way through high school have difficulty with this, remembering it, and also they're being exposed to scientific notation, possibly for the first time in any real situation. They might have encountered math quickly, but they kind of get lost, and they haven't had a lot of time with it, so it might be kind of new to them. So, just a few little pointers in all of this in asking that. Basically, we're looking at three motions in this activity, so they get a chance to uh, play with that formula. They're going to be eventually dividing this by the period of rotation or revolution, whatever, to get a velocity. So if we look at now that they're going to go and the numbers are not just given to them, so they're probably going to online. And the first one's looking for the radius of the Earth. Pictures indicating that somebody at the equator is going to go on a bigger path than somebody just spinning at the North Pole. And they're going to ask a question like, "What is the radius of the Earth?" So they'll come up with a number. This activity is asking them to put it into kilometers. So without much difficulty, there's nice conversions that can be done right in Google if they're online or on their phones. All that they would have to do, type a number in and pick the right units. So we wanted kilometers, so they're going to get a number like that. Uh, this isn't too bad because we're dealing with 6,400 kilometers in that range. If they figure out how many seconds are in a day, then they're going to have 86,000 in some. So those are numbers that can easily be put into a calculator. They don't necessarily need the scientific notation. Uh, you can ask them to do that if you want it on all problems. When we step out towards the solar system distances, we're getting into bigger numbers. So uh, just cutting to the chase, the distance from the Earth to the Sun is 1 AU, 150 million kilometers or so, and they find the circumference of that, and they'll have something like 9 times 10 to the 8 kilometers. They'll have a little bit more solid of a number than that, but just the idea that that's what's happening. If they extend the idea that there are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 365 days in a year, if they want to do 365.25, that's all fine. They'll get a number. One of the niceties of this activity is that numbers will vary a little bit depending on what they find. But in the end, they should end up with something like keeping the numbers simple, 3 times 10 to the 7 seconds. And they're going to be asked to find the speed. So this is where calculator difficulties run in. If we just open a calculator right here, if we read it, it's 9 times 10 to the 8 divided by 3 times 10 to the 7. And if they type it in that way, if they say 9 times 10 to the power of 8 divided by 3 times 10 to the power of 7 equals, they'll get a very impressive number, which is many millions or billions of times faster than the speed of light, and they'll write it down without thinking about it and move on with their life. Uh, so they've typed it in that way. That's not good. So I try to promote them to use the exponent button if they have it. I can see it in here. It's right around in here somewhere. Let's delete that. So if they say 9e8 divided by 3E7. I'll get a nice answer, which is much closer to real. That'll be something that you will encounter a lot as a teacher with students that just have made calculator errors. So that's one thing I'd like to point out in this activity. Another kind of strange one is that when we get down to the last one, we have to know how far away the sun is away from the center of the galaxy in its orbit around the galaxy, finding that circular path. And if they type in uh, how far is the sun from the center of the Milky Way, there's a big old giant number sitting right there, which is the diameter of the Milky Way. So that you get this little text box that comes up often when you ask a question. So if you read down in there, it says it's about 100,000 light years across. The sun does not lie at the center. It's about 8 kiloparsecs, which is a new unit in that space. So have them dig around a little bit, depending on how they ask their question. They should get from 25,000 light years to 28,000 light years. This one is definitely wrong, and it's just that, but it's based on, if you look up in the Google bar, probably the easiest question, the most straightforward question to ask is find the number. So that's just a slight oddity to look out for. The rest, I'll trust that you can do the math, and hopefully you found this a helpful tutorial to go along with the activity on how fast are we moving.